The first example says that a furniture manufacturer is willing to supply X office desks at a price of P equals your supply function, X squared plus 15X dollars each. And the consumers are willing to buy X of these desks at a price of, here's your demand function, 800 minus 5X dollars each. So X stands for your quantity. X is your quantity in both contexts. X is your quantity. And that'll be true for all of the examples that we'll see. X is quantity. Sometimes the functions will be in terms of Q, and that means that Q stands for quantity as well. So the first thing we're going to do is sketch the graphs of both supply and demand on the same axes. So I want to see them both together, and you want to label the graphs, which one's supply, which one's demand, find the y-intercept so that you have some sort of reference, and then label the axes with the correct units. Find the equilibrium point and quantity, that price, equilibrium price and quantity that go along with those two functions. All right, so here we go. I'm only concerned about the positive portion, so I'm not going to leave a lot of space where things would be negative, right? Positive X values make sense. So X in this case stands for office desks. That's a quantity. And the y-axis is price per desk. My price axis. Your supply function is a parabola that opens up, and the demand is a straight line that is moving down at a constant slope. And so the supply function also hits the origin because that's when x equals 0. So the supply function, parabolic hitting there, is going to be something like this. Call that supply. And then my demand function is a straight line, has a y-intercept of 800, and it goes downward like this. So we're going to call that D. And if you want to use your graphing calculator to see what those graphs look like, feel free. Just keep in mind you'll have to find your own window, and that can be kind of tricky. So get lots of practice on finding the window so you don't waste time on the test. The point of equilibrium is right here. So I want to calculate that value of X and the corresponding value of Y because that's the price. Okay, X is your quantity and Y is your price. And so we're going to do that by setting the two functions equal to each other. X squared plus 15X equals 800 minus 5x. Solve for x, so bring everything to one side. Attempt to solve by factoring. Let's see, 20x and 800. I believe we're going to use something like 40 and 20. How about x plus 40, x minus 20? And you're going to FOIL to check just to verify that you've got that correct before you make any other mistakes later. So I don't care about the answer that's negative. I only care about the answer that's positive. So 20 is the one to go with. So 20 is my quantity that's going to put my market in equilibrium. I have to figure out the corresponding price. And so I can either use supply or demand to figure out what that price would be because they're going to be equal. Use whichever one you think is easier. So I'm going to plug it into demand. This work. 5 times 20 is 100. 800 minus 100 is 700. And that's a price. So put some dollars on that. And $700 goes right about there. Okay. Now I did say to label your y-intercepts. So the supply crosses the y-axis at 0, whereas the demand function crosses the price axis at 800. Okay. So it's labeled with all of the information that was requested. And we found the equilibrium point. Next, part B, label the region that represents consumer surplus and then the region that represents producer surplus. And I believe I was using blue for consumers. So that's this piece here. And so I'm going to label that consumer surplus. And I was using red for producers, right? So that goes down here. And so that red region is producers surplus. And it tells you in part B to find the consumer surplus. So I want to calculate that blue area. So the blue area is found by finding the integral that is beneath the demand function all the way from 0 to 20. So here's the big picture. Here's the big picture that I'm trying to calculate. And from that, I am going to subtract this little green section there. See what's going on? And so the integral is going to use, the consumer surplus is going to use the integral first from 0 to 20 of the demand function, which was 800 minus 5x. And then it's going to subtract the amount that the consumer actually paid, which is the green rectangle, whose area is 20 times 700. All right, that was the whole point of finding that point of equilibrium. And the leftover piece is going to be what's on top. So I'm going to shade that in extra blue. That's what I'm going to end up getting for my answer. All right, so integrate 800 minus 5x, we get 800x minus 5x squared over 2. This bound goes from 0 to 20. Then you're going to subtract, what is that, 14,000 from that answer. So if you work it out, top upper bound minus the lower bound, you end up getting an answer that looks like 1,000. Consumers saved $1,000, and they're pretty happy about that. Okay, number 3. Now we have, again, we have supply and demand. But if I look ahead, we're going to be looking for producer surplus. Okay, so I'm going to sketch the graph first of supply and demand. Now, supply is a quadratic, which is parabola that opens up. Demand is parabola that goes down. And so, once again, I only care about quadrant 1. So supply, let's see, hits the origin, and then it opens up. So let's make it do like that. Supply. And demand opens down, hits the y-axis at 150, which I know by plugging in 0 for x right there. And so going down gives you the demand function like that. And there's your point of equilibrium that we have to calculate first. So I'm going to set supply equal to demand, x squared plus 20x equals 150 minus x squared. Get everything onto one side so we can factor and solve for x. Now that it's equal to 0, start factoring. So divide everything out by that common factor of 2. Makes your numbers smaller, a little bit easier to work with, I think. And then try to factor. So find 2 factors of negative 75 that add up to 10. So I'm thinking 25 and 3, but that doesn't work. 15 sounds promising. 15 goes into 75 5 times. So let's go x plus 15x minus 5. Whoops. Didn't need the x there. X minus 5. Do a quick FOIL to check just to be sure that you've got that right. No sense in making a mistake here. I don't care about the negative answer, so this one is no good. I just care about the positive answer because it doesn't make sense for a negative quantity of storage cabinets to be demanded or sold here. So just 5 is good. Then you have to find the corresponding price. To find the corresponding price, you're going to plug 5 back into either supply or demand. It doesn't matter which one you use. I'm going to use supply just because it looks a little easier. I don't know why. But so we get 5 squared plus 20 times 5. And that's 25 plus 100. And that's 125. And that's my dollars. That's 100. $125 is the price that puts me at equilibrium. I didn't do a very good job labeling my axes. X stands for the number of, I don't know, storage cabinets. Here, let's put it down here. X storage cabinets. And the y-axis stands for price. Price per cabinet. The y-intercept for supply is at 0 and for demand is at 150. I labeled those. Anything else? Correct units, done. Label the graphs, S and D. Yeah, looks good. Okay, now in part B, we're going to label the regions that represent producer surplus and consumer surplus. So consumers is on top, right? It's underneath demand. And producers down here, right there. It's above supply. And we're going to calculate the producer's surplus. So I'm going to find that red area. So you remember that green rectangle I keep referring to? That's here. That's the money that was actually paid out for this commodity. So I'm going to find producer's surplus, and that green rectangle is bigger than the red region. And you always want to do the bigger piece minus the smaller piece. So that's why we start producer's surplus with the big rectangle area, right? 125 times 5 minus the integral, which is going to be, the integral that I'm calculating right now is going to be giving me this piece underneath the supply function. So this goes from 0 to 5. The supply, let's see what that equation was. X squared plus 20x with respect to x. And that's going to give you 625 minus x cubed over 3 plus, let's see, 20x squared over 2 is the same thing as just 10x squared because the 2's cancel out, 0 to 5. And work it out. Double check my answer. I got $333.33 for producer surplus, which is this piece. Okay, so that takes you to the end of that example. So we've done one with producer surplus, one with consumer surplus. You'll notice that producer surplus has the area of the rectangle first. Area of the rectangle comes first. That's the area of my rectangle, right? That's the area of the rectangle. And then the integral contains the supply function, okay? Whereas demand is used for consumer surplus. So back up here for consumers, we did the integral first, which is the demand function. That's the demand function. And then the area of the rectangle comes after. So there's my area rectangle. So either learn why they're in that order or memorize it, or if you're starting a note card for your next test, put that on the note card. Now, example 4 is the last example for this section. It's going to combine both topics into the same problem. So you're going to do everything we've just done for part A. You're going to do the sketch, you're going to do the labeling, you're going to find the equilibrium, price, and quantity. But then when you get to B, it's actually 2 problems in one because you need to find both producers and consumer surplus. So you're going to show both of those definite integrals. You're going to write out all of the steps. You're going to include all of the details. You're going to give me both of those calculated answers. Those are in dollars this time, just like before. And that is going to be what I would want to see for the quiz over 5.5. Quiz 5.5 solution is due to the assignment Dropbox by 4/24, which is a Friday at 8 a.m. So that's a Friday. So don't wait too long, get that done. If you want to send it over, have me look at it a day ahead of time, I'm happy to look at your work to let you know if you're on the right track. So that's due on the 24th.